Now, I mentioned ligands, and ligands are something that attaches directly to the metal. Now, in the previous examples, I showed some ligands that only attach in one position. NH3 only has one nitrogen, one lone pair. It can only attach in one spot. But there are ligands where more than one spot could attach to the metal at the same time. And we call these chelating ligands. Chelating ligands attach in at least two or more spots. Now, all of the examples that I've drawn up here have a coordination number of 2. They can attach in 2 spots to the metal. So, ethylenediamine, which is just a kind of just a nitrogen group right here, an amine, so very similar to our NH3, our ammonia, but these two are attached to each other using a CH2 and another CH2. So, two CH2s are called ethylene. Just by themselves, it would be a double bond there, and then we put 2 amines on it, so diamine. So that's where we get the name, ethylenediamine. And this can attach at this nitrogen and that nitrogen. And it's a much stronger interaction. This interaction is driven by entropy. How is that? Well, we can only attach 3 of these to an octahedral complex, but then 6 ligands will come off of that complex when we attach this on. So we're introducing more objects, more disorder, if you want to think of it that way, into the system, and that's a favorable process. So when we're comparing this to just NH3 versus ethylenediamine, delta H actually is very similar because this is a nitrogen bonding to the metal, and that is too, and so is ammonia. Same type of bond, very, very similar electronic behavior between this compound and ammonia. However, in this case, we're going to bond 3 of these to the metal, and we will release 6 ligands from the metal, and that is an entropically favored process. So that's where the chelation effect occurs. Also, when one of these attaches, then it's very quick for the second one to attach because it's already in proximity with the metal, and there's just a much higher likelihood of this colliding with the metal for the reaction to happen. Remember, for a reaction to happen, we must have a collision, and it must be of sufficient energy and the right orientation. Well, by attaching one side of this ligand to the metal, we're increasing the chance of this second nitrogen hitting it drastically over something that is free to just move around. All right, so that's enough about how chelating ligands actually bind. Let's talk about the different names of these. So this is ethylenediamine, but often we don't want to write out the entire name, so we just abbreviate this EN. And here we have bipyrididyl, which is just 2 pyridine rings attached to each other, and you can put the metal right here, right in between these 2 nitrogens, and it's abbreviated BIPY, B-I-P-Y. We have 1,10-phenanthroline, which is abbreviated PHEN, P-H-E-N, and that one is very similar to our bipyrididyl, except it has an additional ring here. So those are all nitrogen-focused ligands, but we can also have oxygens doing the donation. Oxygen has lone pairs, and they are available to the metal. So here's the oxalate anion, and it's capable of chelating and it's abbreviated OX. Now, it typically bonds through this oxygen here. It just has a little bit more space for the metal to sit. We also have the acetyl acetone, which is the ACAC ligand, also abbreviated ACAC, and it's very simply just these two ketones. So you take acetone and put an acyl group on it, this is an acyl group, and so then you have that, and then the metal would sit there. And then very similar to that, just so that my drawings had a completeness here, I added 1,3-diketamines, and they're commonly abbreviated NAC-NAC. And it has nothing to do with the original name here. It's actually called NAC-NAC because it's very similar to the ACAC ligand structure, except with nitrogen. So we just put an N in there to indicate nitrogen ACAC. And in fact, when you want to use this type of ligand, you can start from that one and do a very simple transformation to convert it over into the NAC-NAC form. So these are chelating ligands and their names.